Welcome. Today we are going to look at flight data recorders. Flight data recorders. And by the time we finish this topic, you should be able to state the purpose and explain the operation of flight data recording systems and their components. Flight data recorder, mainly called the black box, but in reality it is an orange box. So the flight data recorder and the cockpit voice recorder CVR, they are all bright orange colored devices and they are called black boxes. Modern cockpit voice recorders, they are made of solid state units. By solid state I mean semiconductor devices. They don't have moving parts with high survivability. The information is stored digitally in a solid state. A crash protected container capable of surviving temperature greater than 1100 degrees Celsius records up to 4 audio tracks. So you can see this thing is capable of withstanding a crash and temperature above 1100 degrees Celsius. So it is very difficult for it to be destroyed. Modern FDRs keep track of over 700 parameters, including time, vertical speed indicator VSI, airspeed, longitudinal acceleration, altitude, engine thrust, heading, elevator, pitch, and roll. You can see the examples of these FDRs as demonstrated in various aircrafts, and it is installed in the rear of the aircraft, encased in hardened stainless steel or titanium capsule capable of withstanding an impact of 3,400 Gs. That means titanium is a very strong metal that can withstand impact, and had stainless steel, so they use any of those. Penetration resistance is tested with a 500 pounds dropped 10 feet with a 1/4 inch diameter steel rod aimed at the capsule's weakest point. Crash resistance tested by applying 5,000 pounds for 5 minutes. Heat resistance tested at 1100 degrees Celsius for 13 minutes. Duration of the jet fuel fire test is 10 hours at 260 degrees Celsius. The capsule water pressure test is survival for 30 days at a pressure of 20,000 feet depth with salt water corrosion. So these are all the tests that they do on this flight data recorder, and if it passes them, then it is fit. These boxes are actually tough. Crash survivability. FDRs crash protected to survive high-speed impact and post-impact fire. However, sometimes they are destroyed or deformed. The data, not the recorder, must survive the accident. Components that need to survive are mounted outside the container. Components that need not survive are mounted outside the container. Definitely those that are needed are always in the interior parts of the container. If an accident occurred at night in a remote area or at sea, The flight data recorders may be the principal, if not only, means of establishing the sequence of events immediately preceding the accident. Many accidents involved aircraft without flight data recorders, and despite thorough investigation, the factors underlying these circumstances occurrences remain inconclusive and unknown. On the other hand, accidents leaving very little recoverable aircraft wreckage have been resolved once the flight data recorder were found. Flight data recorder trace recorders. Early FDRs recorded parameters on a moving roll of metallic foil. Trace recording FDR uses aluminium or high nickel content steel foil tape. Later, the magnetic tape replaced the foil and recorded more detailed information. Advanced recorders use digital devices to store flight information on computer chips. We see the electromagnetic recording, how it was done. Electromagnetic method of recording uses a magnetic tape method which records digitized information onto the tape. The tape is usually a half-inch, that is 12.5 millimeter wide, approximately 850 feet, which is 255 meters in length. Okay. It contains the last 25 hours of data and is on a continuous loop format. If recorders contain crucial data needed to unravel the mysteries behind an aircraft accident, each aircraft has a CVR and FDR installed. FDRs have been on flight since the beginning of the jet age in 1958. The CVRs first entered service in 1967. Most CVRs today are analog recorders using magnetic tape as the recording medium. Recently, solid-state CVRs, in which the audio information is sampled, digitized, recorded, and transferred into memory chips for storage, have become available. Solid-state, very efficient. Modern FDRs are mostly digital recorders using magnetic tape as the recording medium. As with CVRs, solid-state FDRs are now available, in which the recorded and digitized data is stored in memory chips. If the entire aircraft were made of the material that protects the recorders, it would never get off the ground because they are very heavy. Cockpit voice recorder, flight safety box designed to record all radio signals transmitted and received, all intercom and verbal conversations, and all other tones or warnings or noises in the cockpit area. That's what is called cockpit voice recorder. Everything had in the cockpit: the radio signals received and transmitted, the intercom between the pilots, the verbal communications, and all other tones or warnings and noises in the cockpit area. CVR handles it. It records the most recent 30 minutes worth of data, continually overwritten, stroke updated. A typical cockpit voice recorder records 4 channels continuously and separately. We have channel 1, flight interphone, the crew intercom, and passenger address. Channel 2, the first officer's audio. Channel 3, the captain's audio. Channel 4, all cockpit audio picked up by the overhead cockpit microphone. The recorded conversations can be quickly erased, but only when the aircraft is on ground. The park brake is set and raise button is pressed for 15 seconds. It can be quickly raised only when the aircraft is on ground. If not on ground, it can't be erased. And you have to press the erase button for 15 seconds. FDRs record flight parameters, range, and quantity of data recorded varies widely depending upon the age and size of the aircraft. The minimum requirement is a basic group of 5 parameters: the time, pressure, altitude, indicate the airspeed, magnetic heading, vertical acceleration, and microphone keying. The microphone keying is the time radio transmissions were made by the crew and is recorded to correlate FDR and CVR information. We can see where the FDR is located. It's around here on the tail, something here. Flight data recorders are normally located near the aircraft's tail, as experience has shown that this area generally suffers the least damage during an aircraft. Area around FDR and CVR are padded and insulated to afford as much protection as possible. You can check this one, and in the Ugandan laws, the accident as well as the EASA laws, the accident related for investigations can be found in the Civil Aviation Incident Regulations Schedule 5. The encoding panel or data entry panel permits manual entry of data. Depending on the system fitted, this information is usually flight number, date, takeoff gross weight, waypoint reference, leg or sector being flown. Located in the flight station, modern DEPs, data entry panels, permits natural and quick touchscreen data entry and system control. DEP can also contain interactive fault indication system. It allows the crew to gain information on specific components or a system fault indication. Flight data acquisition unit. This receives various inputs from sensors, transducers, voltage, and current sources. It provides excitation for various sensors. It converts analog inputs to digital format. It generates a master clock pulse. It interfaces with management control unit. It provides digital information to the digital flight data recorder for tape storage. The flight data acquisition unit has a MART-pin connector on the front panel. It permits in situ testing, that is on-board testing, data recovery, or bench testing. Built-in test equipment annunciator indicates fault or no fault situation during system self-test. So this is the signal conditioning unit, and it typically integrated into the flight data acquisition unit. It interprets the data provided. It modifies analog inputs as necessary. It does amplification, filtering, modulating, and it performs ADC, analog to digital conversion. We see the digital flight data recorder, DFDR. It receives digitally encoded information from the flight data acquisition unit, records the information on magnetic tape. DFDR has a underwater locator beacon attached to case. Aids accident investigators to find the unit when aircraft has crashed in water. The DFDR contains all the recorded data, must be very strongly constructed to protect recorded data from damage by impact, water, and fire. So it must be strongly constructed. So when it is underwater, it has a locator beacon. That beacon will always give signals to indicate it gives out signals at a given frequency. The flight data acquisition unit is the interface which interprets and formats the sample data and provides it to the digital flight data recorder for recording. The DFDR is a box which provides crash investigation information. The FDAU is only an interface box. We can see where these units are found. This is the reflective tape. This is the underwater beacon.
If they ask me to choose between you and a trip to America, I probably be thinking about you in a plane.
Thematic. FDEP can also contain interactive. FDEP, what is that? Something. Okay. Contains the interactive fault indication system. Allows the crew to gain information on specific components or a system fault indication. Flight data entry, something. Okay. We can see the accelerometer, the management control unit, the aft cargo compartment. This is where the DFDR is, in the cargo compartment, the radio rack, then the flight data acquisition unit. The flight data recording system includes a self-contained accelerometer, which is separate from the normal aircraft attitude sensing equipment to provide lateral, vertical, longitudinal acceleration references. So it is independent of the aircraft accelerometer, which detects movement in 3 axes. The MCU, Management Control Unit, stands alone or can be combined into the Flight Data Acquisition Unit. The MCU controls the recording data obtained from the FDAU and arranges the information to be passed to the DFDR. Data discovery. First, the tape of solid-state memory is removed from the damaged or destroyed FDR. You first remove the tape of the solid state. Sometimes portions of the tape are damaged, but all undamaged portions are read, and overall scenario is reconstructed using readable data. The undamaged memory medium is installed in a functional computer or a tape reader, and data is transferred into the investigator's computer system. The data can be read from installed undamaged FDRs and is commonly utilized by engineers to monitor system status. In this case, the data reader is connected to FDR in situ and data is downloaded for later interpretation. Some systems have removable magnetic tapes which are periodically replaced. On removal, the data is downloaded in the workshop environment utilizing a dedicated tape reader. The erased tape can then be reinstalled. Optical fiber flight data recording. The optical fiber systems are cost effective for flight data acquisition systems 8-bit flight data recording instruments. To meet monitoring requirement, it requires a lot of sensors and data movement. Optical fiber systems provide flexible, affordable, simple, and safe data gathering capabilities. The date when the aircraft was manufactured, number of flight data items required, date compliance required. Before the flight data acquisition units, FDIUs are required. Number of flight data items required, 18. Compliance not applicable. After FDIUs required, but before October 1999, the flight data items required were 22. That was August 2001 when you were supposed to comply. After October 1991, but before 2000 August, the flight data items required were 34. After August 2000, 88 flight data items were required. Recovered data from a trace recording, that's the data analysis. Air Traffic Safety Board in Canberra houses FDR laboratory. The primary function to recover CVR and FDR data for investigation purposes for OST and OS. In addition to its recorder readout capability, ATSB has advanced computer graphics software which allows data obtained from all available sources to be combined to create a graphical reconstruction of the sequence of events in an aircraft or incident. Performance measurement. FDR systems improved a secondary function, that of performance measurement. Performance measurement enables engineers and flight crew interrogate the entire flight performance characteristics for the given conditions of the flight. The FDIU can be tested or downloaded at a workbench situation or in situ. LAM can access data and perform interface tests when FDR is installed in aircraft. Download from FDR in situ for quality checks at regular intervals. If an aircraft is involved in an accident such as severe turbulence resulting in injury to packs or crew, the flight recorder is changed immediately on landing and quarantined for dispatch. CASA for analysis. Now that you have completed this topic, you should be able to state the purpose and explain the operation of the flight data recording systems and their components. Thank you. To take you through the recap, we saw that the FDR records all the flight data, the outside and the parameters of the aircraft, the air time, the pressure, altitude, indicated airspeed, the magnetic heading, vertical acceleration, microphone, and then the cockpit voice recorder. It records the flight interphone and passenger address, first officer's audio, captain's audio, and the all cockpit audio picked up by the overhead microphone. That's it for now. We meet.